Hey Ligers, it's Miss Weiser. This video is going through the real numbers notes. So I'm going through using the Cornell note format. If you haven't heard of Cornell notes, they are created by Cornell University and they're proven to be one of the best way to take notes. So in this format, we have the questions on the left and the notes on the right, and at the end we write a summary. So we are talking about real numbers today. And I know some people are like, wait, real numbers, are there such thing as fake numbers? Yes, but we call them imaginary, and you'll learn about those later on. Our essential question that we're answering today is, what are rational and irrational numbers? And what are some examples of them? Now, this topic is called real numbers because rational and irrational numbers, those two types are what make up real numbers. So all rational and irrational make up what's called the real numbers. So the first question is, what is a rational number? And if you look at it, if you look at the word rational, the very, very first part of it has the word ratio in it. Ratio, rational. And a rational number is a number that can be written as a fraction of two whole numbers. So right there, a fraction is a ratio. So that's why it's called rational. It's because it can be written as a ratio or a fraction. So some examples that I have would be like a whole number 4 is a rational number because you can write it as 4 over 1. Or we have like 3.5, which is a decimal that ends, or a decimal that terminates is the term that we use in math. 3.5 can be written as 7 over 2, so 3.5 is rational. Or we have 0.33333333, which is the same as 0.3 repeating. That bar over it means that it's repeating. And that we can write as 1/3. So it can be written as a fraction. Or like you have 0.121212, which is the same as 0.12 repeating. And that can be written as 6 over 50. So all of these numbers can be written as fractions, and any number that is like a whole number, like 4, or a decimal that ends, like 3.5, or a decimal that repeats the same numbers over and over again, like 1/3, which is 0.3 repeating, or 0.12 repeating, those are all considered rational numbers. The next type of number that we have is called an irrational number. And anytime you have ir at the beginning of something, that just means not. So this means not rational numbers. So an irrational number is any number that when written in decimal form, it goes on forever and does not repeat the same group of numbers. These numbers cannot be written as fractions, and that's because it's not rational, so it can't be written as a ratio. So some examples of these types of numbers would be the number pi. Pi is irrational because it goes on forever. It doesn't repeat the same group of numbers. And we know it's 3.1415 yada, yada, yada. It keeps going forever and ever. It does not repeat. Another example is square root of 2, and we'll talk about what that means in just a second. Square root is the next thing we go over, but it is an example of an irrational number. Or any number that's just a decimal, it keeps on going and doesn't repeat the same numbers. So like negative 3.2305 whatever, 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 whatever. And the dot, dot, dot means that it keeps going and it keeps doing whatever it's doing. And right now it's not really doing anything. It's just kind of random. So it'll be random. It's just going to keep being random. Or another example, this has a pattern, 2.12, 112, 1112. It has a pattern and that pattern will keep going, but because it's not repeating the exact same group of numbers over and over again, it's not considered rational. So that square root that I was talking about, that's the next question. What is a square root? Square root is it's when you have a number that when multiplied by itself, it equals the given number. And every positive number has a positive and negative square root. So we have something that's called a perfect square. Perfect squares are the product, the answer to a multiplication problem, of an integer, positive and negative whole numbers, and itself. So if I take like 5 times 5, that answer would be a perfect square, or -3 times -3, that answer would be a perfect square. All perfect squares are rational, and all other squares are irrational. So let me give you some examples. If we have square root of 36, so I want a number multiplied by itself that gives me 36, and that would be either 6 or -6, because 6 times 6 is 36, or -6 times -6 is 36. So it's a number multiplied by itself to give me that answer 36. And because it's a perfect square, it has this perfect integer, 6 or -6, it's considered rational. But if we had something like the square root of 45, if I put that in my calculator, it gives me 6.7082039325. And then some calculators end there, but really this would go on forever without repeating. The reason calculators end is because they give you 10 digits after the decimal and then stop. But in real life, this number keeps going. So this one would be irrational. It's not a perfect whole number or whole negative number, which are called integers. It keeps going, but it also doesn't repeat. So those are square roots, rational and irrational. And just so you know, it's called a square root because it's the side length of a square with that area. So it's called a square root because if you take a square with the area 36, my side length would be 6 or -6. But we're not really going to have a side length of -6 because we don't talk about distance as negative. And then like if I have a square with the area 45, the side length would be about 6.71-ish. Okay, now we have cube roots. Cube roots of a number is a number that when multiplied by itself 3 times, it equals the given number. So instead of just multiplying it by itself, it has to be multiplied 3 times to get that number. So perfect squares are the product, or excuse me, perfect cubes are the product of an integer and itself 3 times. Perfect cubes are rational, and all other cubes are irrational. So examples of cube roots, like if we had, and it looks like this, it has a little 3 and then the square root, that's called a cube root. So if we have the cube root of 125, we want to know what number multiplied by itself 3 times gives me 125, and that would be 5. 5 times 5 times 5 equals 125. This one doesn't have a positive and a negative, because if I did -5 times -5 times -5, that would be -125, not positive. So cube roots only have one answer, unlike square roots that have two answers. And because this one gave me a whole number, this cube root is considered rational. But if I take like the cube root of 100, my calculator would give me 4.64158883361, and then most calculators stop because they stop at 10 digits, but really this would go on forever without repeating the same group of numbers. So this is considered irrational. And we have to be careful because sometimes we think cube root and square root are the same. We know that the square root of 100 would be 10 because 10 times 10 equals 100. But we want what number times itself 3 times would give us 100. So this one's a little bit different. And the reason it's called a cube root is because it's the side length of a cube with that volume. So if I have a cube like a Rubik's cube or an ice cube, and its volume, how much space it takes up, is 125, the side length would be 5. Or if I have a cube that has a volume of 100, then each side length would be about 4.64 inches or feet or centimeters or whatever they're using. Last thing, to approximate roots on a number line, and we're mostly talking about cube roots and square roots that are not perfect. You find which two numbers it would be between. So it may not be exactly on like the line, but it might be between two numbers, and that's what we're going to look at. So if I have like the square root of 22, well, the square root of 16 is 4, and the square root of 25 is 5, and we know 22 is between 16 and 25. So the square root of 22 is going to be between 4 and 5. Because 22 is closer to 25, it's going to be closer to 5. So if I have 4 here, and let's say it's 5 here, square root of 22 would go in between 4 and 5, but a little bit closer to 5 because 22 is closer to 25. Or if I have the cube root, so that little 3 cube root of 40, you would find the 2 that it would go between. So if I have the cube root of 27, 3 times 3 times 3 is 27. So the cube root of 27 is 3. And if I have the cube root of 64, 4 times 4 times 4 is 64. So the cube root of 64 is 4. And 40 is between 27 and 64. So the cube root of 40 will be between the cube root of 27 and the cube root of 64, or between 3 and 4. Because 40 is closer to 27 than it is 64, when I put it on the number line, when I go here and I have 3 and I have 4, or we can even spread this out a little bit. We get to pick where we put the numbers on our number line. But I'm going to put it somewhere between 3 and 4, and because 40 is closer to 27 than it is to 64, I'm going to put the cube root of 40 closer to 3 than I am to 4. So I'm going to put it about here. Cube root of 40. All right. Your next assignment is going to be to write your summary. If you have questions, please email your teacher, and have a great day, Valley.